this is like a Newton's law problem. We're trying to find the acceleration of this box that's being pushed across the floor. A couple quick things I noticed. As soon as I notice that this sliding box, as soon as I notice it's a sliding box, when we're talking about friction, we got to consider which of these mu values we're going to use. Because it's a sliding box, I have to use mu k. Mu k is when one object slides across another. Mu s is if they're at rest. So if the student's pushing the box and it's not moving, then we're going to use the static coefficient of friction. But because it's sliding, we're going to have to use the coefficient of kinetic friction. That's mu k. Okay, so as soon as I see any kind of a Newton's law question like this, the first thing that I always think is we're going to have to draw a free body diagram. So right here, let's do our free body diagram. When we do a free body diagram, we're looking only for the forces that are on the box. So just a reminder, for free body diagrams, we want all our forces pointing outwards from some central dot. So if you want to draw a box, that's fine, but put a dot in the middle of it. Forces all point outwards. The first force that I always think about is force of gravity. Force of gravity we know is mg. We'll stick some numbers in there in a sec, but let's go and just label all of our forces. If the first one I think of is Fg, which is mg, then the second one I think of is normal force. If I'm pushing this thing, or the student is pushing this thing, they're pushing it to one side. We're not told which side, but let's make it to the right. The student's pushing this box to the right. Friction then is back this way. So if the box slides to the right, then friction is opposing that motion, so friction's back to the left. Alright, we know what the mass of the box is. The mass of the box is 10 kilograms, so we can go ahead and sub that in here. Mass is 10, little g, always 9.8 meters per second squared. The force of gravity, 98 newtons. Let's make that a little clearer. 98. There we go. 98 newtons. Normal force is equal to force of gravity. There's a few exceptions to this, but most of the time, at least in grade 11, that's going to be true. If force of gravity is 98 newtons, then the normal force is also 98 newtons. What we're really saying is this force is canceling this force out. Those forces are balanced. That's not true with the applied force and the force of friction, because I know that this box is accelerating, and that's what we're going to try to find out. What is the acceleration? Applied force, we're told what it is. It's 45 newtons. We're going to need to try to solve for friction in order to be able to solve for that acceleration. Let's make this look more like newtons. There we go. Friction, I'm going to come down here to the bottom because I have no room at the side there, but let's change to a different color here. Friction is always mu times the normal force. We just have to make sure we use the right mu. And again, because this box is sliding, I'm going to use mu k, not mu s. So don't add those two things together, mu s and mu k. Don't average them. Choose one or the other. Mu k in this case is 0.25. The normal force, we already figured out, that's 98 newtons. If I multiply those two things together, I get 24.5 newtons. Okay, there's friction. I don't know if I can squeeze that in here, but right here, 24.5 newtons. That's friction. Alright, if I know those two things, or all those forces, I guess, now I'm free to start saying, okay, Newton's second law is sum of F equals ma. I know about my two balanced forces, Fn and Fg, they cancel. So here, when I say sum of F, the forces that are going to go into the net forces just means add all the forces together, add all the unbalanced forces together. Remember, Fn and Fg are balanced, so the forces that I'm left with, my unbalanced forces, are applied force and force of friction. And just keep in mind, the applied force is forwards, the force of friction is backwards, so when I add them, force of friction is going to be negative. And I should have said this earlier, but when I choose my positive directions, I'm going to choose this forwards direction. That's my positive direction. So forwards or to the right here is positive. Up can also be positive, but it doesn't really matter here because our vertical forces cancel out. This is equal to mass times acceleration. Now I can start subbing some numbers in. Applied force, 45 newtons. You can say plus negative friction, which is 24.5 newtons, or you can just say 45 minus 24.5, it's the same thing. Mass is 10 times A. 45 minus 24.5, let's see, that's 20.5 equals 10A. Then I can divide both sides by 10. Here the 10's cancel, and I'm left with acceleration is 2.05 meters per second squared. We can't keep all those digits. Mass is 3 sig digs, so is the applied force, but the friction, the coefficients of friction are only 2 sig digs. So when I write this, I'm going to say acceleration, and here I'm going to make it into a vector. I'll say it's 2.1 meters per second squared, and I'm going to say forwards. You could say to the right, that's true as well. And I'll stick 2 boxes around this thing to say, there's my final answer. What's the acceleration of the box? The acceleration of the box is 2.1 meters per second squared forward. Good, we're done.